Okay, Assalamualaikum and good morning. Today I'm going to make a revision on data statistic analysis. Let's say you have a sample and then you need to know and to measure the concentration of the analyte in this water sample. And then let's say from your experiment, before you do experiment, do you know what is the exact value in this sample of that analyte? For sure, no. I'm also don't know. But we need to know what is the concentration of the analyte. The exact value, we don't know. Only God know. And the exact value, we don't know. Only God know. But we try to get the concentration of the analyte in this sample. Let's say we do an experiment. We measure the concentration of analyte. We do experiment 5 replicate. Let's say this is the data we get. 10.35, 10.75, 10.5, 10.55 and 10.05. This is 5 replicate from our experiment. And then if we do an average of that data, this one set of data, then we get the average is a 10.52. So the average here we call as a experimental mean. Experimental mean. What is the exact value? The exact value we call as a true mean. The symbol is a mu. For the experimental mean is a x bar. That is from our experiment. After we do 5 replicate, 3 maybe, 7 and 10 and so on. It depends on us. How much replicate we want to do an analysis. So that is after our analysis. So the data here 10.52 from our average by using our calculator, we call it a experimental mean. But the question is it the data here is reliable or same with the true mean? We don't know. We just know from our replicate or from our experiment we get that is the data. But we have to make sure we try to confirm, is it the data here, the average here, the experimental mean here is a near or same with the true mean. How to confirm it? By using statistic. To make sure the data here is a reliable or valid. That is the purpose of using statistic after we do an experiment. So if you look in the notes here, the data analysis, errors in chemical analysis and so on, the main concern here is how reliable, how valid are our data. That is our concern. If you go further, okay, this is already stated in the notes. I'm not going to explain. And also this is the standard deviation, how to use. This is the formula to calculate manually by using manually, but you can calculate by using calculator. And hopefully you know how to use your calculator to calculate standard deviation and also mean or average from your set of data. And then this is the variant. I'm not going to explain. Precision. When we do an analysis, there is 2 words come out from our experiment: precision and accuracy. What is precision and what is accuracy is restated in this slide. I'm not going to explain because you can read or you can hear from the slide given before. And then this is the two, but I'm going to discuss this on this. Okay. Use of statistic in data evaluation. So let's say this is our data from 5 replicates. Use of statistic. We are going to use statistic in data evaluation. First, we can use statistic to define the interval range of values around of set mean, and from set mean within which the population mean, which is our true mean, can be expected with a given probability. So the intervals are called confidence limit. We want to know by using statistic to confirm, is it the range from this value, the range which contain probably true mean. We try to find out by using statistic. And also by using statistic, determining the number of replicates required to assure at a desired probability that an experimental mean falls within a predicted interval of values around the population mean. We want to know how much replicate we should do an analysis in our experiment. And then estimating the probability the experimental mean and true value are different, or two experimental mean are different, by using t-test. How to use statistic? This one we are going to discuss later. We have what we call t-test. And then estimating the probability the data from two experiments are different in precision. We want to check from two experiments or from two person do an experiment. Is it that person A and person B have done precision in their analysis? And also we want to check whether method A, we want to develop a new method, which is method A, and then also a new method we call as a method B. We want to compare between these two methods, which is more precise, or the precision is equally to each other. Okay, this is to do by using statistics. We call as a F-test. And then deciding when to accept or reject outliers among replicates, we call as a Q-test. Let's say we have 5 replicates. From this 5 replicate of data, is it one of the data here is outlier? We have to remove first before we do calculation on their average of this set. Let's say from our 5 replicate here, we believe this data is outlier. So we have to check by using statistic under Q-test. Q-test to calculate whether this data is need to remove or not. How to calculate is already stated. It's already in your slide. But I'm going to explain. Okay. Let's say now we go confidence limit and confidence interval. So what is confidence limit? Interval around the mean that probably contains mu or true mean. So the extreme value is a for this one. Okay. And then confidence interval is the magnitude of the confidence limit. And then confidence level fixes the level of probability that the mean is within the confidence limit. Normally we set our confidence limit between from 90% to 99.7%. What is your confidence limit of that confidence interval? That is the question. Normally we set at 95%. What is your confidence limit? You believe that data is correct or not? 99%. You see, 95%. But in normal practice, in statistic, we use 95% confidence limit. And we use 95% confidence limit. How to calculate the confidence limit and confidence interval? Not confidence limit and confidence level. Confidence level. What is your confidence level? You believe that data is correct at 95%, or maybe at 99.7%, and confidence level. And so hopefully you can differentiate between confidence limit, confidence level, and confidence interval and confidence level. How to calculate? And by using this is the confidence limit, and how to calculate is already stated in the notes. I'm not going to explain how, but you need just to use the formula. The formula given. When you need to calculate the confidence level, confidence interval or confidence limit, you have to know what is the number of your replicates. Is it above 20 or below 20? If below 20, the formula is different when above, when the data or replicate is above 20. But normally practice, in our calculation of confidence interval and confidence limit at certain confidence level, is number of replicate is below 20. So the formula we should use, okay, this one. This is the formula how to calculate the confidence interval. So in order to calculate the confidence interval, we have to get the value of t here. How to get the value of t? From the t table. You must remember, if in the note, this is the revision, okay? If our replicate is 5, what is the t value from this table? We must know, we have to consider degree of freedom. If our replicate is 5, so degree of freedom is 4. So what is the t value at certain confidence level? Let's say the question asks you at 95%. Our replicate is 5. So what is the confidence level? What is the t value? It should be, we look at 95%, the number 4. So the t value is a 2.78. So we put in our formula to calculate. And the S here is a standard deviation. You also need to know how to use your calculator. You put into the, then you get the answer. And what is the confidence interval? By using this. This is the true mean, plus minus t from the t table. Here, let's say our replicate is 5, so we go to 4, number 4, because our degree of freedom is 4, and then at 95% confidence level, 2.78. If the question asks you at 99%, we go to this value, and then we put into the formula here, and then we get the, we do calculation, and then we get the confidence interval. And this is how to use by using confidence interval. So values of t at various confidence level is different. You look here, it's different. So what is our confidence level? We determine what is our confidence interval, and also our t value to put into the formula here. So this is the example how to calculate Hopefully you know. So if you do calculation at different confidence level at 95 and 90%, 95% and 99%, we will get the different confidence interval. Why? Because the t value is different. The higher the confidence level we choose, the higher the t value we will get. If you here 90%, 95% and 99%, the higher confidence level, the higher the t value. Okay. So this is that. Hopefully you know how to calculate, because in this question stated 99%, so you use confidence level at 99% confidence level. Okay. And then other usage of confidence interval to determine number of replicate. From this formula, we rearrange the formula, then we get number of replicate. Same like the t value here is same from the t table here. It's already given. I'm not going to discuss this. Okay. But why? Because normally we already set what is the number of replicate we need to do an experiment. Normal practice, the minimum replicate is 3, and minimum replicate which is correct is 3. That is for the lazy man. Actually for the lazy man. Normal practice is 3. And then also to determine the systematic error by using confidence interval. And from the example here, then we know the calculation give confidence limit of this one from our calculation. And then does the true mean belong to the interval? If not, we can say does systematic error. If not, means systematic error present. If yes, random error present. If the value here is outside from this one, from this range of confidence limit, so we can say the question here, does systematic error present? The answer is yes, because the true value here, the true mean here is higher than this one, not belong to this range. So we can say systematic error present. If the value also is lower than this value, then we can say systematic error present. If the value is between this limit or the range here, we can say random error present. Okay, this is enough for today. To calculate confidence interval. And after this, the video, we are going to discuss on this topic. Okay. Estimating the probability, the experimental mean, t-test, estimating the probability, f-test, and q-test. Okay, enough for today. Please read or hear the video.